Bounded monotone conversion theorem. Every bounded monotonic sequence is convergent. We say that a sequence is bounded above by capital M if all of the terms are less than or equal to capital M. We also say that the sequence is bounded below by lowercase m if all of the terms are greater than or equal to little m. A sequence is monotonic if it is either increasing all the way or decreasing all the way. If a sequence is bounded above by capital M and it is monotonic increasing, then it is convergent. If a sequence is bounded below by the lowercase m and it is monotonic decreasing, then it is convergent. Take the case where the sequence is increasing, monotonic, and is it bounded above by capital M. If the sequence is bounded above by capital M, then the terms cannot be more than m. At the same time, the sequence is increasing, so any of the next term is going to be higher than the previous term. Thus, at some point n, all of the terms stay within the epsilon band, which is precisely the definition of the limit. That is, at some point capital N, a sub n is less than or equal to m minus epsilon for any arbitrary epsilon. This is the definition that a sub n has a limit L. That is, at n go to infinity, all of the terms a sub n stay within the epsilon band, and as n go to infinity, a sub n go to L, the next term a sub n plus 1 also go to L. This means the sequence a sub n converges. If it is convergent, then the limit is unique. The theorem is very powerful because even though it doesn't tell us how to find the limit L, it says that if the sequence is increasing and it is bounded above, then the limit exists. Once we know that the limit exists, using the fact that the limit is unique, we will be able to figure out the limit. Thus, even though we don't know what the limit is, we know that the sequence is convergent. For example, the recursive definition a sub 1 equals 2, a sub n equals 1/2 times the quantity a sub n minus 1 plus 2 over a sub n minus 1. We claim that this sequence is bounded and monotonic. In fact, it is bounded below and decreasing. This is justified using the principle of mathematical induction. Thus, by the bounded monotonic convergent sequence theorem, the sequence converges. But if the sequence converges, then a sub n go to L and a sub n minus 1 go to L, the same limit L, as n go to infinity. The recursive definition a sub n equals 1/2 times the quantity a sub n minus 1 plus 2 over a sub n minus 1 gives us the equation L equals 1/2 times the quantity L plus 2 over L. Solving for L, we will get L equals plus or minus the square root of 2, but all of the terms in the sequence are positive, so L equals the square root of 2.